we've developed the concept that NPR equals the number of ways that you can choose R objects from N objects where order is important. And we've developed the rule that that's equal to N factorial over N minus R factorial. Okay, so we'll just see how we can put this to use to count the number of ways that certain events may occur. So we have the letters things, T-H-I-N-G-S. There are 6 different letters. T-H-I-N-G-S. And if you wanted to work out the number of ways you could form, now when we're talking about words in this scenario, we're not talking about words that are actually in the dictionary, we're just talking about the way that the letters can be organised, different ways the letters can be organised. So we've got 6 different letters there, 1, 2, 3, 4, 5, 6. So how many? Let's go 6-letter words. Now what that is asking us to do is how many ways can we choose 6 from these 6? If we use the rule for NPR, we've got 6P6, so we want to choose 6 from 6, and order is important. So my N is 6, so it'll be 6 factorial over 6 minus 6 factorial. Now 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So all the factors all the way down to 1. All over, now 6 minus 6 is 0 factorial. Now 0 factorial is equal to 1. So 0 factorial is equal to 1. And so what have we got here? 6 5's 30, 120, 720. Okay, so we've got 720 ways that we can choose 6 letters from 6 letters. So how many 1-letter words? Let's be a bit ridiculous here. 1-letter words. Now your common sense would tell you there will be 6 ways, because you could choose the T, you could choose the H or the I or the N or the G or the S. How does this stack up though using this formula? So we'll have 6P1 equals 6 times 5 times, so it's 6 factorial, 4 times 3 times 2 times 1, all over. Now 1, it's N minus R, so 6 minus 1 is 5, so it's 5 factorial. 5 factorial is 5 times 4, 3 times 2 times 1, and you can see that all of those will cancel with all of those, and we're just left 6 ways. Okay, so that's 1-letter words, and let's, for something different, we'll go how many 3-letter words? So you're going to choose 3 letters from T-H-I-N-G-S, and if you choose H-I-N, well, a H-I-N is going to be different to a N-I-H, as different to I-H-N, etc., etc., etc. So order is important, is what we mean by that. So 3-letter words from 6 is 6P3, and that is 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, all over. 6 minus 3 is 3, so it'll be 3 times 2 times 1. 3 times 2 times 1s will cancel. 6 5's are 30, and 4 30 is 120 ways. So you can make 120 words, 3-letter words, if you've got 6 to choose from. Now, all of these examples we've done have to do with no repetition. So how many 6-letter words if repetition is allowed. As soon as we got repetition, it's not a permutation. So we go back to our fundamental theory, counting theory. We've got 6-letter words and we've got 6 to choose from. How many ways can I choose that? 6. Repetition is allowed. So having used a letter there is no restriction on what I use there. So the total number of ways of forming a 6-letter word from 6 if repetition is allowed is just 6 to the power of 6.